In this video, we're going to solve some more trigonometric equations involving trigonometric functions. So once again, it's going to get a little more complicated than the previous one, as this is the third video on solving trig equations. So let's have a look at the example we're going to do. So solve the equation 2 sine squared x plus cos x equals 1, where x is between 0 and 2 pi. So we can assume we're going to give all our solutions in radians because our range for x is given in radians. And this looks kind of, well, when you first look at it, it looks a bit complicated, looks a bit horrible. How are you going to find an x such that 2 sine squared x plus cos x equals 1? But it's actually not as bad as it looks. The first thing you always try and do with cases like this is you don't want sines and coses. That makes things complicated. So you need to try and change one of these to the other. So try and change the sine to a cos or vice versa. Now, it's hard to change a cos x to a sine x or a sine x to a cos x. There's no simple relationship between the two, but it's very easy to change a sine squared x to a cos squared and vice versa because we do know a relationship. So that's what we're going to do. So we start with what we have, 2 sine squared x plus cos x equals 1. And what we do is we say this is the same as 2 times 1 minus cos squared x plus cos x equals 1. So the sine squared x has become 1 minus cos squared x. Now, if you're wondering why this is, it's because sine squared x plus cos squared x equals 1. This is a very common identity that you should remember. You should know this because you'll probably need to use it a lot if you're doing trigonometry, especially if you're doing problems like this. We've seen this in a previous video, and we've also seen that we can rearrange it to get that sine x squared is equal to 1 minus cos x squared, or cos squared x. So we just take the cos squared x to the other side. And so we've substituted this in for sine squared, so that we have written sine squared x as 1 minus cos squared. Hence why we have this equation now. So let's get rid of this bracket. So we've got 2 times 1 minus cos squared x. If we times the 2 through the bracket, we get 2 times 1 minus, so that's 2, minus 2 times cos squared x, so just 2 cos squared x, plus cos x equals 1. Now we take the 1 to the other side, and we get, well, so if we take the 1 to the other side, we would get a minus 1, but remember there's that 2 at the front, so we would have a 2 minus 1, which is 1. So that's why we have a plus 1 here. And then we have a minus 2 cos squared x, and we have a cos x. So essentially they've stayed the same. The 2 and the 1 on the other side have been combined. We get 2 minus 1, and that's plus 1, equals 0 now. Because we took the 1 over from the right hand side to the left hand side, so 0 was all that was left. So now, well, I don't like having this minus at the front. So essentially, if you look at this, it looks sort of like a quadratic equation. We've got a cos squared term, cos term, and then a constant term. Just like in a quadratic, we might have x squared, an x, and a constant term. We don't like to have a minus at the front if we can avoid it. So let's times both sides by minus 1. So if we times the left-hand side by minus 1, we change the sign of everything, and we get 2 cos squared x minus cos x minus 1. And if we times 0 by minus 1, we just still have 0 on the right-hand side. So now we do the clever bit. Now that we've got everything in terms of coses and various powers of cos, we say that let u equal cos x. So let's make a substitution. So we change every cos x to a u. So we end up with 2 times u squared instead of cos x squared. We've got u squared minus u instead of cos x minus 1. So the cos x has become a u, the cos squared x has become a u squared. And now we do have a quadratic equation. And hopefully we know how to solve these. We just factorize. In this case anyway, we can factorize, and we get this is the same as 2u plus 1 times u minus 1. So if you're not sure how to factorize quadratic equations, you should go and practice that. There is a video in this whole series of videos. There's a different set of videos on algebra, and there are videos on factorizing quadratic equations in that series, so you can go and watch those. So we end up with this, and now we know we can just read the answers off. Either 2u plus 1 is equal to 0, or u minus 1 is equal to 0, and that tells us that u is equal to minus 1/2, or u is equal to 1. Okay, but u was just something we introduced. We actually want to solve for x, and remember u was equal to cos x, so we write that cos x is equal to minus 1/2, or cos x is equal to 1. So now what do we get? Well, we've got two cases, the case where cos x is minus 1/2 and the case where it's 1. We have to treat them separately to get all our solutions. So in the case where cos x is equal to minus 1/2, this tells us that x is equal to 2 pi over 3. So you could find this just by using a calculator. If you do inverse cos of minus 1/2, you would get 2 pi over 3. We actually did this in a previous problem in the Solving Trig Equations 1 video. We had this problem and we found that x is 2 pi over 3, or at least that's one value for x. And you'd either put this into your calculator in radian mode and it would give it you like this, or you would have to get in degrees and convert it. But either way you get this solution. Now, remember our range is 0 to 2 pi, so in that range, are there any more solutions? Well, yes, there are. So let's just look at this cos graph. I'm not going to go into too much detail. We've sort of done this in the previous videos. We've gone into a lot of detail of how to find the solutions looking at the graph. All we're going to know is that 2 pi over 3 is one solution, but cos is symmetrical about pi, so there must be another solution on the other side of pi. Now 2 pi over 3 is a third of pi less than pi, so if you add pi over 3 to 2 pi over 3 you get pi. So if you add pi over 3 to pi, you go up from pi, you'll get 4 pi over 3. So that's another answer. So you can sort of see where these roughly lie on the graph. If you drew a line through the y-axis at minus 1/2, and you looked at what x values were giving you those 2 points on the curve, you'd get 2 pi over 3 and then 4 pi over 3. So then we take case 2, cos of x equals 1. This is easier. You should hopefully know that cos of 0 equals 1. This is quite a common fact and we can see it on the graph. At 0 we're up at 1, and then the next time this happens is after 2 pi when cos gets back to where it started. So you can see that cos goes down and comes back up, and at 2 pi it's back at 1. So essentially every multiple of 2 pi gives you 1 when you put it into cos. So cos of 0, cos of 2 pi, cos of minus 2 pi, it all gives you 1. But if we look at our range, we only want answers in the range 0 to 2 pi inclusively, so 0 and 2 pi are the only two solutions. Anything else would be outside of the range. So these are our 4 final solutions.